Okay, so yesterday we stopped at question 10. So today we will continue with question 11, where we are asked to show that two triangles ABC and BDC are similar. Okay, so I've already given you the first answers to part A, where we prove that two of the angles are the same. So because two angles are the same already, then the third angle must be the same. We quote that since three pairs of corresponding angles are equal, then those two triangles are similar. Then we move on to part D, where we are told to find the length of CD. Okay, now CD is found over here. It is part of the bigger triangle. It is also belonging to the smaller triangle at the same time. So CD, to find the length, just put on the letter CD first. Now we know that it belongs to the one complete side of the smaller triangle, which is known as BDC. So CD, I want to write it over its corresponding side, which is CB. Then I just quickly glance at the picture. Okay, I have the length for BC. Okay, that's good. Now I need another pair of corresponding sides for the small and the big triangle at the same time. Something that is already known. Okay, so do I have many choices? Do I have all three sides of the smaller triangle? We don't have, right? We are told to find one of it, which is CD, but I do know another side, which is BC. This BC, it belongs to the small triangle, it belongs to the big triangle at the same time. Now, BC, I know that value, it is 30. It belongs to the small triangle this time, so BC corresponds to AC. Then I quickly glance to the diagram, AC, I have that value also. So I'm happy. I formed an equation with three values and one unknown. Surely I can do it. So from here, CD over 30 equals to 30 over 45. Therefore, CD must have a value of 900 divided by 45, 20. Okay, so length of CD is done. Found it already, 20 cm. Okay, put it down in your diagram also, in case you need it. So since this is 20 cm, this must clearly be 25. I don't know whether we will need it or not. Okay, so next one, find the value of area BDC over area ABC. BDC over ABC. Okay, these two are similar triangles. As long as I have ratio of the side, I square it, I get the answer. Okay, and I'm pretty sure I have the value. So C part 1, area, triangle BDC, area ABC. Just need a pair of corresponding sides, okay? So small triangle divided by big triangle. So many options you can choose from. For example, your BC over AC, 30 over 45. And we need to square it. Yeah, we get 4 over 9. So the area, the ratio is 4 over 9. We move on to part 2. So before we move on there, I just want to highlight to you that there's a square over here because those two triangles are similar. Okay, because two triangles are similar. That's why we had a square over there. Then we move on to part 2, where we will now see that area of our triangle BDC over area triangle ABD. So BDC, small triangle, ABD is the triangle on top. Clearly they are not similar. So we look for common height. So same thing goes. Go and find all the bases with the corresponding perpendicular height. There will be two perpendicular heights that are common. With that, we can just compare the bases. Okay, so practice enough, you realize that here, we've got one perpendicular height over here. This perpendicular height belongs to both BDC as well as ABD, where the bases are 20 and 25 respectively. So the ratio divided by 5, you get 4/5. Done. So it's usually this is a 1 mark question. We don't expect much working from you. Okay, any questions? Anybody needs time to copy before I erase? Because I need space. Need time, raise hand. So part 2, no square, no need to square because we are talking about triangles having the same height. Not similar, so no need to square. Okay, next one, question 12. Information given, take note that I put it over here 1 and 2 without units. To remind myself, these are ratio 1:2. Now at the same time, please observe that the total over here is 3 in ratio terms, okay? 3 units. Next, information given, 24 square centimeters is the area of that small triangle at the top. So find area of triangle ABC. So this is a common shape, right? The triangles are similar. So go ahead and state that the 2 triangles are similar. Triangle, go ahead and prove them also. So triangle ADE similar to triangle ABC. Then we have the ratio of the sides. So area of triangle ABC, which is the unknown. I always put my unknown on the top left hand corner, okay, when I'm working in fractions like this. So area of triangle ABC divided by area of triangle ADE. So big triangle divided by small triangle. The ratio, because I'm working with similar triangles, it has to have this format. Big length divided by small length. So the big length in this case is 3 units. Divided by 1, which is simply 9. So what we are trying to say over here is that the area of the big triangle is 9 times the area of that small triangle on top. In other words, area triangle ABC must be 9 times of 24. Give us 216. Yes.
What we need to prove that they are similar?
Let me get back to you. It actually also depends on the marks. But let me try and get a confirmation from boss whether need to prove or not. Okay? If you have time, then go ahead and prove lah. Otherwise, you should recognize that these are similar triangles already. Anyway, the proving doesn't take too long, so right. 3 pairs of corresponding angles are equal. Now let's move on to part B. Area of BDE. So BDE, this triangle, it is clearly not similar to any other triangle. But question already provided area of that tiny triangle on top, 24. And in this case, rotate your paper, you will see that they all share the same perpendicular height. Right, whether it is the small triangle, that 24 square centimeters, or area of BDE, with these as the corresponding bases. So area BDE over area of the known triangle, which is ADE, because they have same height, it will be 2/1. Ratio of the bases only. So area triangle BDE will be twice of ADE, 2 of 24. We get 48 square centimeters. One last question. Okay, now we've got a parallelogram. So keywords, all these you might have to know them up. Parallelogram. So opposite sides, parallel opposite sides have the same length. Look at the diagram, you immediately know that the top will be 40 units, 40 cm, okay, 40 cm, 16 plus 24 lah. And then they give us one area, BEF, that is 120 square centimeters. Find the area CDF. CDF, you can tell that this is again similar triangle to the triangle at the bottom. So part A, area CDF. Look at the format. Always put it in terms of a ratio, a fraction, divided by area of triangle, the similar one at the bottom. So since we go CDF, then we start from E to B, then to F. E, B, F. This has to be, because they are similar, area has to be the square of the ratio of the sides. So CDF is the big triangle at the top, the denominator with the small triangle. Do we have a pair of corresponding sides? Have? Derek, have? Big triangle, small triangle. Do you have a pair of corresponding sides? Oh, which are they? 22, 24 and 40. Okay, which one in the numerator, which one in the denominator? Which one on top? Bigger one. So 40 and 24 lah. Okay, so 40 divided by 24. 5 over 3 square, we get 25 over 9. So area CDF will be 25 over 9 times area EBF. So EBF is given to be 120. So, no, isn't it 200? Correct. Wrong, eh? CDF. Yeah, wrong, eh? Don't scare me, eh? You're talking about part A or part B? Then where's my mistake? Is it? 25 divided by 9 times 120. Oh yeah, sorry. Yeah, you're right. So 3, and 1/3 square centimeters. Thank you very much. Part B now. Find area of BCF. Okay, BCF. Now I have the triangle over here. Clearly not similar to any other triangle. Then must find common height already. I've got two other known triangles areas. Okay, so we've got a 3, and 1/3. We've got 120. Now either one, as long as you have ratio of bases with corresponding height the same, it will work. But not necessarily both are viable, because we may not have common height, or we may not have enough information for either triangles. So I'll just randomly I'll just randomly choose the bigger triangle first, the 3, and 1/3. If I were to use that 3, and 1/3, and I choose the base to be common, okay, over here. If this is my perpendicular, okay, can you see that this big triangle and the shaded blue color have the same perpendicular height? Now, where are the bases? Where are the bases? DB, a DF, okay. So for the yellow triangle, the base is DF. Okay, wait. So this is the orange color base for the yellow triangle. For the blue color triangle, this is the base, right? If I have the ratio of these two sides, I confirm I can find the area of the shaded triangle, blue color triangle. But how to find the ratio of these two bases? Do you remember that we have similar triangles over here? This yellow triangle and this triangle, they are similar, right? Right. This yellow one and this one, they are similar. The corresponding sides are over here. Right? These two triangles are the bases belong to two other triangles and they are corresponding sides of similar triangle. I don't need to know the actual length. As long as I know the ratio can already. Since they are similar triangles, right, ratio of all the corresponding sides must be the same. Do I know any ratio of the big triangle on top to the small triangle at the bottom? Have, right? 40 and 24. So in simplest term, 40 divided by 24, how much is that? 40 divided by 24. We got 5 to 3. In other words, I've got 5 units over here and 3 units over here. The ratio of the bases is 5 to 3. So part B, if I want area of BCF divided by BCF, area triangle CDF, it is going to be 3 over 5. And I know my denominator, triangle BCF, that's what we want to find. So that's 3 over 5 times 3, 3, 3, and 1/3. To give us 200. Okay, now at this point, do you all have easier method? Have? I believe some of you may have an easier method, but this is the first one that I came up with. Okay, if you want to copy this, go ahead. But there might be an easier method, which we will take a look in a short while. Okay, anybody needs more time for this? Okay, you want faster copy? I'm trying to figure out what's the easier method. Okay, anybody needs more time? Clarice done? Okay, yes, what is the easier method now? Area of triangle BEF, wait BEF, what about it? Same height as triangle BCF, so you're referring to this perpendicular height, isn't it? Okay, then?
Since I have area of BEF, I can use that to find
We have area of BEF. So this was known to be 120 square centimeters. Then what do you do? So you still need the 3 and the 5 lah. Okay, then it's yeah, it's the same lah. It's just you use this triangle instead of this triangle. Okay? So both will work. Next one, to find the, what do we do? Oh, so what's the answer for BCF? I've got BCF. This one was 200, right? Then 333 and 1/3. And the last one, 120 square centimeters. Okay, now part C, they ask us to find the area of the parallelogram ABCD. Huh? DCB times 2, yes. So our parallelogram is actually twice of this highlighted area. Because the diagonal is going to split it into 2 equal parts. So this will be 2 times of 333, 1/3 plus 200. 1066 and 2/3. Can. You can. Okay. So very good question. Can I leave it as improper, which is 3200 over 3? Let's look at all the options we have. 1066.6.7 or 1070. Okay, so I've got 1, 2, 3, 4 answers over here. I gave you the first answer, 1066 point and 2/3. So confirm correct one. Okay. Now, how about the second one? Can I accept? Can? Is it exact? Yes, right? It is. Can accept. But if you have to choose between the first and the second, which one is more readable? Readable as in easier to understand. You are able to have a better sense of the number. First one or second one? First one, right? Because first one you can tell, okay, yeah, it's about 1066 plus a little bit 2/3. Whereas the second number, you still need to do a little bit of mental calculation. Oh, it's about 3000 divided by 3, that's about 1000 to get a feel of the number. So the preferred presentation in this particular case, because there's a story behind it, we're trying to find area. This is preferred. The second one, 3200 divided by 3 is not wrong. Not preferred though. How about 1066.7, 5 SF? Can or cannot? Can? Why want to put 5 SF?
Normally the question say leave your answer in
No, the question usually doesn't say leave in how many SF. If you look at your N-level paper, O-level paper, the cover page, they always say the same thing. What do they say?
3SF.
No, they don't say leave 3 SF. They say leave non-exact answers in 3 SF. You know what that means? Non-exact. What kind of numbers are we talking about? Numbers that are non-exact
Cannot be fraction.
cannot be fraction. Irrational, they are talking about irrational numbers. Numbers such as 3 pi. It is not exact one. 3 times pi, you get a 9.4247 da 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 da. This is when you put it as 3SF. So 9.42. Numbers such as square root 2 over 5. In your calculator you get 0.28284. Round it off to 3SF, 0.283. These are the cases you leave as 3SF. Numbers such as 1, 2, 1 over 3. Yeah. If you try in your calculator, you get 40.3 recurring. You cannot round this off to 3SF. You cannot say that this is equal to 40.333 and then, oh, let's round it off to 40.3. Aren't you losing accuracy? Right. So this, we don't want. You're losing accuracy. So in the same with the same logic, we do not accept this. We definitely do not accept this. Because you have an option to leave it as exact. You better leave it as exact. Okay, so that is all for our 3.3. We move on now to 3.4. Ratio of volumes of similar solids. Okay, now previously we did similar shapes. That's 2D. What happened when we had to find the ratio of area for similar shapes? So area 1 over area 2 is the same as length 1 over length 2. But we had to square it. Correct? This is a summary of what we have done for similar shapes. Now, similar shapes, we had this particular relationship. We investigated why. We tried finding the areas of similar triangles, squares, circles, rectangles. Turns out, it is simply the square of the ratio of the sides. We're going to do the same for similar solids. So 3D this time. This was 2D. Now we move on to 3D. Okay, let's take a look. If you have a cube, I don't need to do all this again. Just pay attention. Javier? Focusing. Need to watch face. Okay, so we've got cubes. Obviously, cubes are similar solids. Ratio of the sides confirm the same one. 5 and 10. The ratio is 1:2. But when we talk about the volume, you take the 5 times the 5 times the 5 to get the volume of the first cube. And that gives us, I believe, 125. So volume is 125 cubic centimeters. This will be 1000 cubic centimeters. If you take their ratio, it ends up being 1:8. Okay? We take a look at, by the way, this is the same as 1:2, but we cube all of them. 1 cube to 2 cube. You know, in our area, I made you write it this way. Ratio equals to 5/10 cube, which is half cube, which is 1/8. 1/8. That is where that 2 cube became. The 2 cube became 8. 1 cube is just 1. You go on to square pyramids. Here we have base, the side of the base, in this case which is a square, is 4. So 4 to 6, put down 4/6, you get 2/3. So ratio wise, you put 2:3. If you compare the height, you get the same thing, 6 to 9, which is also 2:3. Why? Because they are similar. Confirm the corresponding sides have the same ratio. And you go on to talk about the ratio of the volume. So what then is the formula for volume of a pyramid? Do you remember? 1/3? Very good. So I'm going to put it down as a fraction. 1/3. 1/3 base area. Base area will be 4 times 4, so 4 square, times the perpendicular height, which is 6, divided by 1/3 base area, 6 square, times the perpendicular height, which is 9. What do you notice? Anything can cancel? Half and half. Oh, sorry, 1/3 and 1/3, yes, cancel. Oh, cancel, cancel. Oh, that 4 square and the 6 square. You know, if I were to separate them, this is what it's going to look like. Yeah. 4, 6, divided by 6, 6 and 9. Correct? Then if I go and cancel each of them, you see what I will get. 4 and 6 becomes 2 and 3. 4 and 6, 2 and 3. 6 and 9, 2 and 3. Any surprises? Not surprised, right? We expect it to be the case. So turns out the ratio is just 2/3 cube. Where did the 2/3 come from? Hey, ratio of side was 2/3. The ratio of volume is actually 2/3 cube, which is 8/27. You put it down in the proper ratio form, we get 8/27. You get how this works? So instead of going through all this extra work, when I give you the ratio of the side, I expect you to straight away tell me ratio of volume, 2 cube to 3 cube, 8/27. Just as you will be able to tell me ratio of area is just square, 4 to 9. Volume, cube, 8/27. Okay, we go on with a few more. Ratio of sides, whether you want to choose 9 to 15 or 6 to 10, you are going to end up with the same simplified ratio. Okay, so in this case, let me just choose 6 to 10, which is 3/5. Now if you go with the 9 to 15, you also get 3 to 5. Ratio of volume, you know what? I'm going to skip all the extra step. I'm going to put 3/5 and I cube it. 3 cube, 27. 5 cube, 125. Done. I don't need to calculate everything from scratch. So in the final case, in the case of a sphere, if the ratio of the radii, they chose radii as the measure of length. They didn't have to, they could have used circumference. Compare circumference, you get the same thing. Then the ratio of volume, you should expect it to become A cubed to B cubed. Done, that's it. Another period, right? Okay, one more period. So in summary, we cube for volume, we square for area. Is that easy to remember? Why is it easy to remember? You cube for volume, you square for area. Does it sound familiar?
This one is 3,
One is 3, one is 2. What is the unit for area? Huh? Square centimeter, right? There's a square. There is a reason for that. What is the volume for? What is the unit for volume? Cube law, similar for solids. So this will be 3D. Volume 1 over volume 2 is actually length 1 over length 2, but we cube them. This is the summary. And the link between area and volume, is there a link between them? Can I go from ratio of area straight away to ratio of volume? Or must I go one round? Is there a relationship between ratio of area and ratio of volume? Direct relationship. Not too obvious at the moment. But once I have ratio of area, in the event I have this, I can calculate this. Once I have this, I can calculate this, and I can get this. Okay, so this is the flow you must have. To go from area to volume or volume to area, you have to go through the side. Garrick, you need to wash your face? Okay, then just one quick work example. We got two similar basins, height 16 cm, 20 cm respectively. No other lengths given to you. Find ratio of base area A to area B. So 16 to 20, right? L1 over LA. This is another presentation you can use. Since we have diagram A and diagram B, I call it length A divided by length B. I get 16 over 20. Simplify it. Divide by 4, 4 over 5. Now, what about area? A over area B. That has to be 4 over 5 squared. And we get 16 to 25. Done. Ratio of area. Then we go on to talk about capacity. That is ratio of volume this time. Ratio of volume, simple lah. Change the area to become volume. Volume. Change the square to become cube. The answer will also change. 64 to 125. Done. So you try now. Exercise. Try 17. Two similar drums. Height 40 and 30. Remember to reduce them, becomes 4 to 3. Find the area of top to the area of the other top. Then find ratio of volume. Okay, go ahead and do it now. Look at my presentation. Part A, area of the top C to top of D. So part A, area C over area D. Take note, I avoid using A for area. Can you imagine in the previous question, if they talk about area for part A, right? If I write AA over AB, wow, very confusing, right? So area, I spell it out. Volume, I spell it out if it happens to have any chance of confusion. So this, I spell it out. Area C over area D. It has to be the ratio of sides squared. It has to look like this. So the length of C over the length of D. Which length do I have? I only have one. So 40 over 30 is squared, you get 16 over 9. So since they wanted ratio equals to 16 to 9. So for part B, do the same working, volume C volume D. So 4 over 3 cube, and we get ratio equals to 64 to 27. Oh, very fast one. Just immediately can write down already. JV, are you doing fine? Not doing fine. Oh, okay, please go ahead. Okay, now the next example over 18 over here, we got ratio of base area of two similar solid cylinders, 9 to 16. These numbers, be sensitive to them. They are perfect squares. There is a hint that you might want to try square rooting if you're desperate. But we are not desperate. We know that eventually we have to square root, because these are ratio of the areas. So find the ratio of the radii, meaning the ratio of length for these two cylinders. So part A, this is my presentation. Area, large or small, over area big, equals to 9 over 16. So the radius, small, over radius big, must be square root 9 over 16, which is 3 over 4. So ratio is 3 to 4. Done. Quite clear. I do not need to write any extra stuff. Then ratio of volume, right? Part B. Volume big over small first, huh? Just try to be consistent. Small over volume big. Must be 3 over 4, and we cube it. So 27 over 64. So ratio is 27 to 64. Done. The final part. Okay, this is something new. If the mass of the smaller cylinder 540 grams, find the mass of the larger cylinder. Hey, why suddenly talking about mass this time? I thought we were talking about volume. We were talking about area, volume, length. Why suddenly got mass? How is mass related to anything else you have seen over here? Related to volume. How is mass related to volume? Huh? Density, yeah, density. So it depends on the question. This is a solid copper cylinder. It is a solid mass. Whether it's a big cylinder, small cylinder, they have a uniform density. Okay, so the bigger the volume, the bigger the mass. The smaller the mass, the smaller the volume. It is proportional. So the relationship between ratio of mass is actually the same as ratio of volume. They're directly proportional. And it has to make sense to you. Garrick, focus, important. Okay, now, so this is the key over here. Please highlight it in your textbook. Mass of the cylinder is proportional to its volume. Reason, I elaborate a bit for you. The reason is because same density.
Actually, still don't make sense to me.
Why?
Why mass is related to volume?
Why is mass? Oh, okay, let's prove it. What's the formula for density? Density, this is how you write density, right? Oh man, why you all give me this confused look? Don't you all write density like this? This one lah. Okay, never mind. Density equals to mass over volume. Okay? So now my goal is to prove to you, when mass increase, volume will increase. Okay? For a constant density, same material, this has to be constant. So I've got to cross multiply density times volume equals to mass. This is a constant. So my volume is directly proportional to mass. When mass goes up, volume has to go up. The other way around is true. When volume goes up, mass has to go up. When volume goes down, mass has to go down. Directly proportional. Okay? No cube, no square. Mass, volume, directly proportional. So now they want the mass of the, they tell you the mass of a smaller cylinder is 540, find the mass of the larger cylinder. Very easy. But see, mass, big. But they want to find big one, right? Okay. Mass big, divide by mass small. Because whatever unknown I need, I put at the top. Mass small. Equal to the same as volume, because it's directly proportional. And we had the relationship for volume already. Small to big is 27 to 64. Now I need to flip it around. 64 over 27. Okay, this side is big over small. So the mass big must be 64 over 27 multiplied by the small mass, which is given to be 540. So 540 divided by 27, that gives us 20 times 64, 1280 grams. Yes? Okay. After this, you finish 19 already. Okay, so those who haven't done, do exercise example 19 now.
I think we still try 18.
Huh? Yeah. See wrong. Try it 18, do it now. Okay, if you have already done that, yeah, you try it, you also do already. That means you're asking for homework question. Homework question is this. Exercise 3.4, question 3, 5, 6, 7, 9. 3, 5, 6, 7, 9. Oh, you laugh. Yeah, don't worry. 3, 5, 6, 7, 9. If no time, then I will reduce that. Okay, so but please now try it 18. Make sure you get the basics correct first. Ratio of the corresponding sides. So in the question they gave you areas ratio 25 to 49. Small to big. So for the sides, small to the side that is big. It will be 25 over 49, but you have to square root, which gives us 5 over 7. Okay, so the ratio is 5 to 7. Part A. Now they want the ratio of volume. Volume small over volume big. Must be 5 over 7 power 3. 125 over 34. 343, Thank you. So the ratio is 125 to 343. Now part C, that's the one we are interested in. The mass of the larger is 686. Find the mass of the smaller. So the mass small over mass big is the same ratio as the volume, 125, 343. We have the mass of the big cube. So mass small is 125 over 343 multiplied by 686, which is 250. Got it? You must look at the presentation. I try to make life easy for you. Don't need to write a lot of things.